Chapter 2, Lesson 6 of Pre-Calculus, looking at graphs of rational functions, and we want to take a short video and look at the reciprocal function in particular. The reciprocal function is the function that has the form 1 over x, which is a rational function, but we can use this parent function and then use this the knowledge of transformations that we have in order to shift this function right or left, up or down, and those types of things. So the parent function, you'll notice, has an asymptote at y equals 0, a horizontal line at y equals 0, or in behavior. You'll notice that it approaches the same number from the left and to the right, and a vertical asymptote at x equals 0. Again, as you approach 0 from the right, it goes up towards positive infinity. As you approach 0 from the left, it goes towards negative infinity. So because it goes towards infinity, approaching this value from both sides, this is a vertical asymptote. So this would be the parent function, and then everything else we know about transformations will apply to this function here. Meaning, if I were to add a value on the outside here, let me change colors here. If I was to add a value up out here, this would shift the entire function up 3. So the horizontal asymptote would be up at here, y equals 3. The vertical asymptote would still be here. And this point 1, 1, and this point negative 1, negative 1 would also be shifted up 3. So this point would be now here at 1, 4, and this would be at 1, 2. Okay, or negative 1, 2. So adding a number to the outside will shift it up or down, just like all the other functions we've looked at in the past. Also, putting a number next to it, like this, that's going to make a horizontal shift, so this will shift it to the left or right 3. This particular case would shift it to the right 3. So this horizontal, or vertical asymptote would be over here at x plus 3, and then everything gets shifted to the right. Again, you'll want to look at this key point here, 1, 1, which is on the graph, and so that would be shifted to the right 3. This point, negative 1, negative 1, be shifted to the right 3, and then you would have your graph, okay? So those transformations apply. If we put a number in the numerator, meaning we say, let's say 2 over x, okay, well that's going to be a vertical stretch or shrink, because we can always factor this 2 out, put it in the front, 2 times 1 over x, because now this would just multiply to this. You can see that when we multiply a number by the entire function, you remember that's a vertical stretch or shrink, so this would be a vertical stretch of 2. So once we have it in this form, any number in the front is a vertical stretch or shrink, any number outside is a vertical shift up or down, and then your horizontal shifts are in here, and then again if you change the x value, that's going to be a horizontal stretch or shrink. So all those things that we've learned about other functions applies to these functions. Now sometimes it's not obvious to see the functions like it is in the other, to see the transformations as in other functions. So a little thing you'll have to remember that is this, that if the degree of the numerator and the degree of the denominator are the same, you're going to have to use polynomial division or synthetic division to rewrite the function, or to get it back in this form so that you can actually see what the transformations are. Now, the best way, again, I think, for me to show you that, or to, is for me to give you an example. Okay, so if we have the case, for this case, let's say 2 over x plus 3, what is the transformation of the shift? So this is similar to what I said before. Anytime there's a number in the numerator, you can simply factor that out and put it in front, and so now you can see the shifts and the transformations. The 2 is a vertical stretch of 2. This is a number larger than 1, and the x plus 3 means this is a shift to the left 3. Okay, so that shift is the same as always. That one's pretty easy to see. What if you have something like this? Now this isn't as easy to see. This is the case that I was talking to you about before. The degree of the numerator and the degree of the denominator are the same. So what you'll want to do is to use synthetic division to divide this out and put your remainder over the divisor. Okay, so we're going to divide by the 0, that's at 2, and then we're going to list our coefficients, 3 and negative 7. We bring the 3 down, 2 times 3 is 6, and then we add. So now because this was at 1, when I put the variables back in, this is no longer a 1, this is there is no variable here, so this is 3. with a remainder of -1, and I put -1 over the divisor. So this gives me 3, then minus 1 over x minus 2. Or, because this is in the front, I can move it to the back end here, and you'll see now it's easy to see what these shifts are. This negative sign is a reflection over the x-axis. This is a shift to the right 2, and then this is a shift up 3. So we can describe those transformations. So if the degrees are the same, then you'll want to divide this out until you get down to this nice little number that doesn't have a variable, and then you'll have your transformation, which are more easily seen in this manner.